Alright, so I'm going to talk about data link layer switching. So first off, just a little reminder about what the data link layer is. It's one of the 7 layers in the OSI reference model. It transforms raw transmission facilities into lines that appear to be free of undetected errors. And it does this basically by splitting data into frames and then sending out the frames sequentially and waiting for an acknowledgement frame before sending the next one. So if you have multiple LANs, local area networks that you want to connect together, one way to do it is bridges. And the first bridge I want to talk about is the learning bridge. They're called learning bridges because they basically populate the table that you just saw in that video as it goes. The table starts out empty, and then it learns which stations are connected through what ports as it goes. It also has a routing procedure that it follows for each frame that it receives. And then I'll give a couple examples of the procedures on the next slide because I have some examples. So the routing procedure, if the destination port is the same as the source port, then it discards the frame. Basically, it means the computers are on the same local area network, so when it broadcasts the frame, the computer already received the frame, so it doesn't need to send it out anywhere. If the destination port is not the same as the source port, it sends the frame to whatever the destination port is. Say, if you want to send computer A to computer B and they're on different LAN, you would go through the bridge. And then if the destination port is not known, then it uses something called flooding to send the frame to all the ports on the bridge except for the source port. And so here is a couple examples of some learning bridges. So say you wanted to send a message from A to F, but you've never sent a message from A before, and it doesn't know where F is on the network. A will broadcast its frame, and that frame will be taken into bridge 1 through port 1, and then bridge 1 says, I've never gotten a message from A before, so it stores that A is accessible through port 1 in its table. And then, since it doesn't know where F is, it broadcasts the signal to all non-source ports. So since 1 is the port that the source frame came into, it sends it out through all other ports, which is just port 2, so then it reaches F. And so then I'm actually gonna ask a question now. So what way is there in the second diagram here on the right, what way is there for the first, if you'll recall it, so the first routing procedure, if the destination port is the same as the source port, you would discard the frame. So taking into account what you saw in the video and this diagram, what 2 ports would have to be talking to each other for that procedure to take place? Yep. So what two terminals here would have to be communicating with each other for the first procedure here, the destination port and the source port being equal on the bridges? So there's 2 bridges here and they each have 4 ports. Which 2 terminals communicating with each other would have the same destination and source port? Yeah. Yep, that's correct. Because the hub here transmits the frame on all ports except for the source port. So say E wants to send a message to F, it sends it to the hub, and then the hub broadcasts it to the bridge and to F. And then once it reaches the bridge sees that E is accessible on port 2, or F is accessible on port 2, and that's the port that it received the message, so it doesn't need to do anything because F will have already received the frame. So then the next type of bridge I want to talk about is the spanning tree bridge, and so basically in order to increase redundancy in bridge networks, they'll have multiple channels connecting the same bridges together. But that creates something called loops in the topology, which is basically an infinite loop that can occur if the destination port isn't known. And you overcome it basically by creating a spanning tree of of the topology of the network. So say, and so you first have to pick a root node. So here, let me look at this. So here is an example of a spanning tree bridge diagram. So this is a net, and you see if it had these connections, it would have loops within the topology. So it picks a root bridge, which in this one is B1, and it decides that by broadcasting a message every once in a while, and inside that message there's an identification number embedded in it, and the lowest identification number is based on a MAC address, so it's unique to each bridge. The lowest one gets selected as the root, and then it creates a spanning tree, which is just the shortest path to each bridge from the root. So you see, if you wanted to send a message from B5 to B4, you wouldn't send it along here, you would send it all the way around. And that prevents what's seen in this diagram, which is a loop in the topology. So if you send a frame from A, frame 0, and you want to send it to an unknown terminal, you send it to B1, and then B1 doesn't know where to send it, so it broadcasts it using to every port, and then B2 also doesn't know where to send it, so it broadcasts it, and it doesn't know that it's the same frame, so it broadcasts the same frames back to B1, and then B1 broadcasts them back to B2, and then they go back and forth forever. So this prevents that from happening. So, so lastly, I just wanted to cover a little bit. So this is just a little thing that shows which device, is in which layer. And so we're in the data link layer, so we're dealing with bridges and switches. So switches are just modern bridges. Basically, they're almost interchangeable. So one difference is that bridges tend to connect fewer LANs than switches, and modern installations, so switches tend to have point-to-point links, so they can have more ports, and they're almost interchangeable, but one of the main differences is just in terminology. Switch is a broader term. Switches can refer to things other than network switches, while bridges are just network bridges. And so one of the questions that I wanted to ask was, where are hubs located? What layer are hubs located in?
They're located in the physical layer. Right.
Yep.
And the previous question?
Oh yeah,
Which group were you?
okay, so both. All right.
All right, so before I go into